Welcome back, all my good humans. Today I'm going to discuss with you how to multiply and divide expressions with radicals. Say for instance, we live inside a box, and in that box there are two dimensions that make up that box. We have the length and the width. And if we're given the area of the box and we are asked to find the length and the width of the box, we can do so. In order to do so, we need to find the square root of the area to give us the dimension of the length and the dimension of the width. Now, to find the square root of a number, we must use this symbol called the radical sign, or we can say the square root symbol. The square root of a number is a number such that when you multiply it by itself, is going to give you that number. So say for instance, the square root of 25 is going to be 5. When you do 5 times 5, that will give you 25. In other words, we'll say that the dimension for the length is 5 units and the dimension for the width is also 5 units. When we are dealing with expressions that contains radicals, there are 3 basic rules that we need to adhere to. Rule number 1, if we have the square root of a variable, could be a, raised to the second power, which is our exponent in this case, then it is going to be a, because the exponent 2 is going to cancel out the radical sign. And we can also take this further and say that the square root of a number, say 3 raised to the second power, is going to be 3, because when we cancel out the exponent with the radical sign, we will get 3. Okay, so that's the first rule. So we can take this further and go along now and work with rule number 2. Sometimes when we are doing problems that deals with rule number 2, we have to integrate rule number 1 into that problem also. Rule number 2 is that if we are multiplying an expression, right, we have to break it up. We have to separate them. So if we are given the square root of a and b, or a times b, we are going to break it up as the square root of a times the square root of b. You are going to separate them, okay? And this, I'm going to give you a prime example. Prime example is the expression square root of 4x to the second power. Now we know that the square root of 4, we have to break it down, and then we have to find the square root of x to the second power. Now the square root of 4 is simply 2, and the square root of x to the second power is simply x. Square root of 4x to the second power is going to be 2x, and that is your final answer. Okay? Now, if we are given a expression that doesn't have any variable there, it just have a number, a monomial constant, a number that stands by itself, we can further do the math on this. Say for instance, we asked to break this down, simplify radical 72. The first thing we must do with radical 72 is that we're going to break it down into 2 factors. One is going to be a perfect square, and the other is going to be a non-perfect square. But we must shoot to find the perfect square that is going to be the greatest number, or the greatest perfect square. So we are going to shoot for factors such as radical 36 and radical 2. All right, that's what we are going to use. So radical 36 we know off the top is going to be 6. And radical 2, we just bring down our radical 2. So our answer here is 6 radical 2 as your answer. But there are cases when sometimes we don't remember the greatest factor such that is a perfect square, and we might say, okay, let's try this one. We have radical 72 here, and we decided to do radical 9 and radical 8. Fine. You can do that. You now notice that when you simplify radical 9, it's going to be 3. And when you have radical 8, you can find a perfect square, which is square root of 4 and square root of 2. Now, you will end up with 3 times, this is 2, times radical 2. So your answer here is also going to be 6 radical 2. You notice here that your answer is the same. The only difference is that you got to your answer faster because you had less steps, whereas over here you had to break it down again and you had more steps to work with. So be careful there, okay? Now let's get to rule number 3. Rule number 3 states that if you are finding the radical of a fraction, you have to break them up. So if you are to find the square root 7 over 25, you have to further break this down. You're going to have radical 7 over radical 25. We can go ahead and find our answer here, which we know radical 25 is going to be 5, and the square root of 7 or radical 7 is just going to remain, and this is going to be your answer. But you may have a different situation where you will have to simplify radical 49 over 3. And so you have to break this down as radical 49 over radical 3. Now radical 49 is going to be 7 over radical 3. One thing I must say to you, do not make the mistake and write this as your final answer. No, this cannot be your final answer. You cannot have a radical symbol in your denominator as your final answer. No, you have to rationalize the denominator. And this is how you do it. So, you are going to take that 7 over radical 3 and you're going to multiply it by what we have as the denominator here, which is equivalent to 1, meaning multiply it by radical 3 over radical 3. This is equivalent to 1. It's just the same concept as when you are multiplying a fraction, right? And then you're going to multiply it by 1. You're going to make that denominator the same. It's the same concept, all right? So with this in mind, what we're going to do next is that we're going to multiply across. So this is going to be 7 radical 3 over radical 3 to the second power. Now we will notice from this that we can go ahead and we can simply cancel that out, which is going to be 3. But then we have the 7 radical 3 at the top, and this is going to be your final answer. Okay? But if you didn't write it like this, when you were doing the calculation, and you wrote it this way, 7 radical 3 over, you multiplying radical 3 times radical 3 is going to give you radical 9. Now because this is radical 9, then you know that the square root of 9 is simply 3, and then you have the 7 radical 3 as your numerator. Now you'll notice that your answer there is the same, okay? Answer is the same. So it is up to you. You have options. You can either write it this way when you are simplifying it, or you can do it this way. You can either raise it to the second power so that you can cancel out the radical symbol, or you can simply multiply the numbers under the radical and keep your radical symbol, because you have 2 radical signs here. So radical with a radical, and then you have a radical symbol, and the number multiplied will give you this number. All right? So that is what you have to be mindful of. There is another example that I want to show you. And this example is, say for instance, if you had radical 54 and x to the 4th power. Okay? You don't have x to the second power here. I spoke to you about the x to the second power rule, where you have the radical sign that is going to cancel out each other. So what you have to do here, you have to break this down. So you're going to break this down, all right, as finding the perfect square, which is square root of 9, the highest one, square root of 9, and square root of 6. Now for the x to the 4th power, you're going to break it down as radical x to the 2nd power times radical x to the 2nd power here. You're going to do that. Now you can apply rule number 1 and simplify this expression. Rule number 1, you are going to cancel this exponent with the radical symbol. You will have x times x, and then the radical 6 is not able to be simplified, so you keep that, and then radical 9 will give you 3. Now you notice I don't want you to give me this as your answer. No, do not give me this as your answer. You're not supposed to write it this way. You have to write it in a way such that you have all your variables and your number in front of the radical sign. So it should be 3x to the 2nd power radical 6, and that should be your final answer. In conclusion, I have just laid out for you the 3 steps. Please adhere to those steps when you are simplifying expressions that deals with radicals, especially when you're multiplying or dividing. Please stay tuned for my upcoming video on adding and subtracting expressions with radicals. Thank you for watching and see you soon. Bye now. Cheers.